Good morning students. In this lecture of mechanics, we will discuss the cross-section of elastic scattering. So far we have discussed that a single incident particle is being incident on single target particle. But now we will discuss that what will happen when you will incident a large number of particles on a target, and target particle, it also consists of large number of particles instead of a single particle. So what are the possibilities when we incident large number of particles on a large number of target particles? So a portion of them may suffer elastic collision. There is possibility of that some of them will suffer elastic collision and some of them will suffer inelastic collision, and there is also possibility that some of them may not suffer any collision at all. It means they will not interact with the target particle at all. So from all these three possibilities, what we can conclude? We can conclude that the angle of scattering, it will vary from 0 to 180 degree. 0 degree will be the angle of scattering for those which don't scatter at all, or you can say that which doesn't undergo any collision or any scattering. The particles which don't undergo any collision or scattering, they will not deflect at all. So that is why their angle of scattering will be 0 degree. And the particles, they will be the particles which will suffer head-on collision. So what they will do? They will be back scattered. So the angle of scattered particle in that case with the direction of incident particle, it will be 180 degree. So angle of scattering, it will vary from 0 degree to 180 degree. So now what we have to calculate is that in any given direction, what is the probability of scattering? Because now there is variation, large variation in angle of scattering, that is 0 degree to 180 degree. So now what we will find is that what is the probability of scattering at any given angle, means in any given direction. So here we will try to find out that what is the probability of scattering in any given direction by using the concept of cross-section. So now we will study that what is this cross-section is all about. So first, the definition of cross-section is, it is that effective area of the target which is exposed by the target to the incident beam of particles during elastic scattering. During elastic scattering, it is that effective area of the target which is exposed by the target to the beam of incident particles. And this scattering cross-section or cross-section of elastic scattering, it is denoted by sigma. SC subscript is used for scattering, and the units of scattering cross-section is barn, and its dimensions, they are of area. So that is why this one barn, it is equal to 10 raised to power minus 28 meters square. So from this you can conclude that the units of scattering cross-section, they are barn, and this barn, it is having the dimensions of area. Now what this cross-section, from this definition, what do you conclude about this cross-section? What does this cross-section means? This cross-section means that when the incident particles, they will strike inside the effective area of the target particle, only then elastic scattering will occur. Elastic scattering, it will occur only if the incident particles, they are striking against the effective area of the target. And if in case these incident particles, they are striking outside the effective area of the target, then there will be no elastic scattering at all. So this is the meaning of cross-section. Next thing is that as I am talking about effective area, what is this effective area? This effective area of the target, it is different from the geometric area of the target. Geometric area of the target is actual area covered by, actual physical area covered by the target. But this effective area, it is different from that. How? I'll discuss now. Now we all know that this elastic scattering or inelastic scattering, everything is in physics, it is not an actual collision. Means it is not actual physical collision. There is just interaction between the incident particle and target particle, and because of that interaction or forces existing between the incident particle and the target particle, these particles get scattered and change their path. They got deflected from their normal path. So that is known as collision in case of physics. So there is not a physical collision. So it means if there is not a physical collision, this collision or scattering, it arises just from the interaction between the two particles. It means the effective area of the target particle, which will cause this elastic scattering, it can be greater than its geometric area. Because the two forces, the forces between the two particles, they exist even at a distance. Therefore, this effective area which will cause the elastic scattering, maybe it can be greater than the geometric area of the target. So that is why this effective area is different, and this effective area of the target, it is always greater than its geometric area. So now we will calculate the expression for this scattering cross section. So as this scattering cross section, it is related to the probability of elastic scattering in any given direction. So first, you all have studied this probability in your mathematics 10+2. So what is the probability? Definition of probability is, here we are taking the probability of elastic scattering. It means it will give you the fraction of particles, fraction of those incident particles which are undergoing elastic scattering. So what will be its definition? Its definition will be, it will be the ratio of the particles, number of particles suffering elastic scattering to the total number of incident particles. So this probability of elastic scattering is the ratio of the number of particles which are undergoing elastic collision to the total number of incident particles. So now we will have incident particles and target particles. And now we don't have a single target particle. Now the target, it consists of n target particles. And suppose the geometric area of the target is capital A. So now we'll discuss about that how many number of particles which we will incident on this system of target particles. So now suppose that the number of incident particles per unit area per second is I. If in the unit area of the target number of incident particles are I, so what will be the number of incident particles which are incidenting on A area of the target? On unit area of the target, number of incident particles is I. On A area of the target, number of incident particles per second will be I into A. It is same, cost of 1 pen is ₹5 and cost of 5 pens will be 5 into 5. So number of incident particles in unit area is I per second. Number of incident particles in A area per second will be I into A. So this is all about number of incident particles in A area of the target per second. Suppose this as equation B. Now out of these particles, how many particles will be scattered by the target? So suppose number of particles elastically scattered by one target particle per second. Suppose it is n, capital N. And how many target particles are there? There are n target particles. So what will be the number of particles elastically scattered by n target particles per second? It will be n into n, small n into capital N. So now put both these values in the definition of probability of elastic scattering. So here the number of particles which are scattered, they are n into n, and the number of particles which we have incident, that is I into A. So now suppose this as equation D. There is another definition of probability. See that also. According to another definition of probability, probability of elastic scattering, it may also be defined as the ratio of effective area of the target to the total geometric area of the target. And we know that geometric area of the target is A. And what is the total effective area of n target particles? We know that effective area of one target particle is sigma. So what will be the effective area of n target particles? It will be n sigma. So put both these values in this equation E. So we have probability of elastic scattering is equal to n sigma, that is effective area, to the geometric area. So now suppose this as equation F. So from equation D and F, both are providing us the probability of elastic scattering. From equation D, probability of elastic scattering is this. And from equation F, probability of elastic scattering is this. So this n and n will be cancelled out. A and A will be cancelled out. So now we have obtained the expression for cross-section of elastic scattering, which is this. What is this? This is the number of particles scattered by one target particle per second. And what is this? This is the number of incident particles per unit area per second. So cross-section is the ratio of number of particles scattered by one target particle per second to the number of particles incident per unit area per second. So this is the definition of sigma scattering. Next we will discuss about impact parameter. What is this impact parameter all about? Now we have any charged particle, have positively charged particle having charge plus z dash e. It is moving in this direction with velocity u vector, and m is the mass of this charged particle. And here at this point we are having atomic nucleus, positively charged atomic nucleus having charge plus Ze, and the perpendicular distance between the two is b. Perpendicular distance between the two is b, and this b is known as impact parameter. Initially, when this charged particle, it is at infinite distance from this atomic nucleus, then at infinite distance there will be no interaction at all between these two. So at that time potential energy of the system will be zero. So the total energy will be purely kinetic in nature. That will be half mu square. So therefore potential energy of the system will be zero and total energy will be equal to half mu square. But when this charged particle, it will start moving towards this atomic nucleus, as the distance between them will decrease, interaction between them will start increasing. And what will be the interaction? As both are positively charged, so there will be force of repulsion. So there will be a point where the force of repulsion will be maximum. So at that point, the charged particle, it will be deflected from its path, and that point is C. So C is the point of closest approach, which is at a distance r0 from the atomic nucleus of charged particle. At this point, the charged particle, it is getting deflected by angle theta with its original direction. So, see. And what is this B? B is the impact parameter. So this B, actually it is the perpendicular distance of this velocity vector of the charged particle from the direction of motion of atomic nucleus. So it is the perpendicular distance of velocity vector u vector from the atomic nucleus, that is known as impact parameter, and it is denoted by B. And the expression for B is this. The derivation of this expression of B, that is not in your syllabus. So now from this expression, what you can conclude about the physical significance of B? What is the physical significance of impact parameter B? First, if in case this impact parameter it is small, then this cot theta by 2, it will also be small. And if the value of cot is small, it means the value of tan is large. And if the value of tan is large, it means theta is also large. So what is theta? It is the angle of scattering. It means corresponding to the smaller value of impact parameter, the angle of scattering will also be large. Corresponding to smaller value of scattering angle, impact parameter will be large. How? You can see, if this perpendicular distance is large, then if the perpendicular distance between the two is large, then the interaction between them will be smaller. If interaction between them will be smaller, it means the deflection will not be large. If deflection will not be large, it means theta will be small. So if B is large, theta will be small. If B is small, it means the distance, perpendicular distance between these two is smaller. It means interaction or the force of repulsion will be greater. If force of repulsion will be greater, it means it will get scattered by the larger angle. So if B is small, then impact of interaction will be large and theta will be large. If in case this impact parameter B is 0, it means if you decrease the perpendicular distance between them is equal to 0, then what will happen? This cot theta by 2, it will also be 0. If cot theta by 2 is 0, what will be the value of tan theta by 2? It will be infinity. And we know that tan is infinite at 90 degree. This means theta by 2 is equal to 90 degree. So what will be theta? It will be 180 degree. Theta 180 degree means there will be head-on collision between the positively charged particle and atomic nucleus.